Okay, so this is supposed to be the second problem of our problem solving corner for Math 215. And this says, take the complex number z equals 3 minus 4i. This is written in a nice form, written in the form of a plus ib, right? Or x plus iy, whatever thing you prefer to write it with. And then it says in question number A is that write it in the polar form, right? The important keyword here is the polar form. And then we know the polar form of a complex number is this, where we have r times e to the power I theta. This is actually the exponential form. We could have also written it with the help of Euler's formula, where we had z equals r times cosine theta plus I sine theta. Right, they're the same form. And r here is called the modulus, and theta here is called the argument. Okay, so asking you to find the polar form of a complex number is equivalent of asking you to find the modulus and the argument of that complex number. And that's what we're going to do. So we know for a complex number, the modulus is written as 2 bars, inside which we write down the complex number z. And this is going to be the real part of the complex number, right? And square that plus the imaginary part of that complex number, and then we square that and we take a square root. So that is the formula. In this case, the real part of z is 3 and the imaginary part of z is minus 4. So if we substitute them in here, what do we get? We get 3 squared, which is 9, and then minus 4 whole squared, which is plus 16. This is a nice number because these two leads to this number 25, which is a square number, and if you take the square root, you get 5. So that's the modulus. What about the argument? Well, the argument of z is written as argument of z. And this is equal to what? It's equal to tan inverse, so tan inverse of y divided by x, where y is the imaginary part. In this case, this is negative 4. And then we have the downstairs x, which is in this case is 3. What do we get? Well, this is not a standard value for which tan inverse is known, but we can always use a calculator. So let me use mine. And my calculator tells me it is equal to negative 0.93 radian. And if this is true for this much radian, then this will be true if I add twice pi or subtract twice pi or add any multiple of them, any multiple of twice pi or negative twice pi. So we write this as twice pi n, where n can be 0 or any positive or negative integer, right? So in that case, how do I write it in the polar form? I can write it as follows. So z equals 5 times e to the power, and then I have I times negative 0.93 radian plus twice pi n, where n is any integer. So that is the polar form for this number. So in the second part of the problem, we have what is the effect of multiplying a complex number by z. So let us take another complex number, which is z1, let's say, and then it's been written as r times e to the power I theta. Now, the reason I'm writing in this form is because it's easier to multiply two complex numbers if they're written in the polar form. And you can notice immediately that if I multiply this with z, what do I get? I get r times 5, and then I have a to the power, so I times theta minus 0.93. I'm presuming theta has also been written in radian, plus twice pi n. So this new number, which is also a complex number, can be written as r and then e to the power I and then capital theta. Okay, so then what happens to the modulus? So the modulus of this new number r is 5 times r. So originally the number we took, for example, as z1 was r, and now the modulus been multiplied by 5, so it has increased by 4 times, right? So before it was just r, and now it's 5r. So if this was the length, then you have almost 5 times the length. Alright, what happens to the argument? Well, the argument is decreased by this amount, right? So for example, if this was r e to the power I theta, so that this would be theta and this would be r, and it has been increased by 5 times. So let's say 1, 2, 3, 4, and then 5. So now this is the new modulus, and it goes in the clockwise direction about 1 radian or 0.93 radian. So it's about 50, actually it's 53 degrees we have done in the in number A, and then it's somewhere in here. So that's what's been happening. So this is z1. This is the effect of multiplying a number by z. And the next one is easier. It says find z cubed. So number C, all you'll have to do is take z cubes. It will give you 5 cubed, and then you have e to the power, and then I times 5 times this negative 0.93. So let me take my calculator. So my calculator says it's 4.65, so negative 4.65 radian. And then of course you'll have to add twice by n. So it's the same point if you rotate it by twice pi in the clockwise or in the anti-clockwise direction. So this is z cubed. Very easy to do if you do it in polar form.